Okay, great. We might not take the full 2 hours today. I just want us to finish the one exam paper prep that we started, and then next week on Tuesday or Wednesday and Thursday, we will work through another paper for your prep for next week Saturday's exam. Okay, so let's look at the next set of questions. Again, I will share the presentation and the recordings on the group later today. So let's see how to work out the last couple of questions for this paper. Okay, so in this instance, we need to work out the roots of a quadratic function are given. They give us the y-intercept, and we need to nearly calculate the coordinates of a turning point. So there's a few things that we have that we need to use. Oh, okay, that sounded like I lost some signal there. Hopefully I'm back. So they tell us the roots of the equation a is 2 and minus 3. So when we work with the roots, we know that this one, the root is 2, and this one, the root is 3. So when we want to calculate our formula, this will be x minus 2, and because that was minus 3, this will be x plus 3. Okay, so that's nearly the first starting point to get to our original formula that we need to work with. Okay, then the other thing we can calculate that now by multiplying out the traditional way. So it will be x squared. It will be plus 3x minus 2x, and then hopefully the minus 6 will be the same as your y-intercept. So at least we now know that that component that we've done is correct, because the y-intercept is also giving us what they told us the y-intercept will be. And now just to look at this in line with how we would traditionally look at how our formulas would look like, so that we can just use some of the information. So the first thing, I want to get the x of a turning point. So x is minus b over 2a. So that's one of the formulas that we can use. So minus b is then minus 3. So that will be that one. Wait, I haven't simplified that above equation. So let's quickly simplify it. So that's x squared plus x minus 6. So actually minus b is going to be minus 1. And then divided by 2a, and a is also 1, so divided by 2. So we sit with x is equal to minus a half. Okay, so we could have gone now already to our answer set and said, okay, it's not option 1 because we're looking for x as a half. Okay, there's x a half, not option 2 or minus a half, and there's option 4. So at the moment, 2 options left nearly for us to consider, option 2 and option 4. So the easiest way now to calculate the y turning point, the y of a turning point, is to put this minus a half back into the original formula. So we have the minus a half to the power of 2 plus minus a half minus 6. Yeah, so in this instance, minus a half times minus a half will be positive 1 over 4. Just that stays minus a half. That stays minus 6. So our final answer will be minus 6 and a quarter. Okay, so we can then go to our answer set and check for minus 6.25. And then we get that as option 2. Okay, so in this one, we basically needed to use the roots to put that first into your equation. Then we just made a sense check to see if our y cutoff is the same or y intercept is the same as they tell us. If it was not, then one needs to go back and check if the roots that you have put in, if that was correct. And then we can simplify and then just remember the formula that we would normally use for a quadratic function, so that one can use that to get to your y or the turning point of your diagram. Okay. So this is also something that they love to ask. It might be that they give you the formula and then ask you to work out the turning point. They might give you a sketch of the formula with some points on it. So dependent on what they, how they want to ask, but there will be something like this in your exam. Now we'll also look at another paper that we'll do next week to check if we can find something like that. Okay, then let's go to the next one. So again, as previously mentioned, I love to shuffle the questions around in your paper so that you nearly get a mix of things next to one another or after one another. So now suddenly from a turning point, we go into that we need to actually work out a marginal revenue. So let's look at what they tell us. The demand function of a firm is that, where P and Q represent the price and quantity respectively. At what value of P is marginal revenue equal to 0? Okay, so now we nearly skip to the last chapter where we need to see, okay, marginal revenue, that was where we needed to differentiate. So we need to look, marginal revenue is actually, we need to differentiate total revenue. So we first will need to work out what is total revenue, and the traditional formula for total revenue, if you can remember that nearly from study unit 1 or 2, is the price that you're selling your product for times how many products you will sell. Remember, that was your total revenue, nearly the price of the products times how many products you will sell. And then in this, we actually have a nice formula for Q. So we can substitute that into Q because they've given it to us. So they might, and that is just where you need to be careful, is they can give you the P as well, and you need to work with Q, because then they might say, then what is the value of Q if marginal revenue is equal to 0? Or it might be that you also, and what I will show here as well, is we will work out the value for P, but we can put that value for P back into the formula to get Q as well. So I will quickly, after we've done the one, just show the other way as well. Okay, so multiply in. So we sit with 60P minus 2.5P to the power of 2. Then we need to differentiate that. So then we sit with, remember it's 60, P will be 1 minus 1, so P to the power of 0 is 1. So we basically sit with 60 times 1. And on this side, the 2 goes in front. 2 times 2.5 is P. And then we sit with P2 minus 1, which is P to the power of 1. Okay, and they tell us this marginal revenue is equal to 0, so we can equate it to equal to 0. And then we can simplify it by saying, okay, let's keep 60 on this side. I'll take minus 5P over, so it becomes positive 5P. And then to isolate P, I divide by 5 on both sides. So 60 divided by 5 is where I get P equal to 12, which is option 2. If I ask you to work out Q, we would just go back and in that formula substitute P, so we can then say, well, Q is 60 minus 2.5 times 12. And that is 60 minus, let me quickly, 2.5 times 12 is 50. So if we needed to work out what Q was, it would have been 50. So just, we didn't need it for this question, but just if needed, and if I ask you what is the value of Q when it marginal revenue is equal to 0, you have that as well. Because again, they could have asked you to work out P and Q. Okay, so they don't only need to stop at the one. They could have asked both ones to calculate. Okay, so just wanted to make sure that you guys can also, if needed, because also when you get a question like this, just be careful and read carefully, because they could have even said to you, instead of a P, set Q, and then one of these options might have been 30. I have seen that happen as well. So just when you read the question, just be very careful of what they are actually asking you to work out. Okay, great. Let's go into the next question. And now, again, you can see suddenly they take us even back now to study unit 1 nearly, or 2, where we needed to look at logs. So again, quite different question that you need to work out, and also can really see that a lot of these answers seems to very or seems very in line with one another. So it might be that when you start working it out, something like the one will have a big influence on your answer. Okay, so let's look at this, and let's first try to simplify that. So I can, on the left-hand side, because of log rules, we have that minus. We can say that Q divided by Q over Q plus 1. Okay, so that we can do because of your log rule, where we have a minus. So that's nearly, I think, log rule 1 or 2 nearly. I will again share my summary formulas that I have written some of the log rules on as well, with you guys on the chat as well. So that's nearly the log rule. So then I said, okay, let's just see that what we need to divide by in just a simpler format. So it's something like that. And then remember that's actually Q over 1 from other work that you guys did, that you can swap that around when we divide. So then it becomes, okay, at least now that seems a bit easier. We only going to work with Q plus 1. So nearly that very difficult equation then becomes a much simpler equation. U plus 1 is equal to 0.8. Okay. Then the next thing, that when there is no number here at the bottom, so let's make it a different color. So when there's no number here, we can assume that it should actually be log to the base of 10. Okay, so that is, and that's how your calculators are also set up. So if you use the log function on calculator or the ln function, it's always to the base of 10. So when there's nothing, it actually means to the base of 10. Okay, so what we will then do is to say, okay, but let's, to get rid of the log on this side, we are going to power everything. So again, this will be one of your log functions, where you can, I think it's log function 3 or 4. So to get rid of logs on both sides, we take E, and then if we take E, that will fall away, and it becomes basically 10 to the power of 0.8. Okay, so now you can see we can work out that 10 to the power of 0.8 first. Okay, so that gives us Q plus 1 is equal to 6,31. Okay, which is that one, but it's not yet that one. So we need to still subtract the 1. So 6.31 minus 1 will give our answer of 5.31. Okay, and that then is option 1. If we had that plus 1 somewhere made it a negative 1, and when you brought it over, you made it positive, there would have been another answer for you. So again, I think this one is where it's difficult is firstly with a log rule of this, where you needed to know that you can say if there's a minus, you can divide it, but very nearly when you simplify that, you get actually a very simple formula. When I originally looked at that, I was like, sure, here we're going into something difficult. But when you actually then simplify it, you get a very nice formula. And then the other thing just to remember is when there is no base, we can take it as the base is 10. And that is standard. So, and that is exactly how it is on your calculators as well. The base is standard of 10. Okay, so that now was a log one. So you can see that nearly for these 3 questions today, it was really going from one to another. So there's no real pattern in your answers or your questions. And then suddenly you go back to how many units must be manufactured to maximize a profit defined by the following function. Okay, so what we can do with this one is there's 2 things that we can do. So we know when you maximize a profit, it happens at the turning point. So at the turning point, you will maximize the profit. Or if it was a positive before the x square, at the turning point, you will minimize the profit. So if it is y is equal to minus x, it will have a view of a quadratic that's going downwards. And what you basically are calculating is at that turning point, what is the maximum. So from question 20 nearly, remember we could work out what is the turning point. So we could say, but my turning point is minus b over 2a, which is minus 1. Okay, so my turning point is where x is 4. And then what I can do to get to the units. So again, if you look at how this one will look, it's not saying that it goes through there. So x is, or q is the value of x. So we know already now the units that we have is 4. So that's fine actually. We know what the units are, so that's actually all that you needed to do. But if you wanted to check what the price is, you can put in the 4 back into Q or into this formula so that you can get what price is. So they just asked you how many units. So units is actually the X value because that is quantity. So with quantity, you were able to work out the units. But just for if I want to ask you what the price is of that 4 units, just put it back into the original formula to get the pricing. So that's 16, so that will become minus 16 plus 52 minus 12, which is also actually 4. Okay, so quite interesting, your price and quantity. So that turning point would have been X4 and Y4. So if you needed to work out the turning point, you would have needed to do that and that. If you needed to only work out the units, it was fine with this formula. If you needed to work out the price, you needed to work the extra one in as well. Okay, so again, for your answer, you could have stopped there already because you only needed to work out the quantity or how many units was manufactured. But if I ask you to go to at what price do you maximize the profit, then you need to work out the pricing component as well. Okay, so I think they will probably in your exam go to the next step as well, that you need to work out pricing, just because again we had something like this here as well. So it might just be that they want you to do it again. Okay, so again, strange the flow of the paper, but we now again looked at maximizing of profit. And then we go into what is this, a cubic function. And in this, they ask us, it has maximum or minimum value. So for what values of x of this function has it a minimum or maximum value? Okay, so again, to get to maximum or minimum values, like we did in all of these, we nearly need to take then what is your first differentiate of that. So we will need to look at differentiation of this function, which is not too bad. If I look at it, the 3 goes in front, 3x, and then 3 minus 1 is 2, plus 2 goes in front, 2 times 3 is 6, x to the power of 1. And because we need to find out if it's a maximum or minimum, it will be equal to 0. Okay, so now the easiest way now is first to, like we did in some or study unit 1, nearly of looking at previous work you guys did, need to simplify first. So we see that in both of these, there's a free x that you can take out. Then what's left in the first term is x. What's left in the second term is plus 2. So if just checking it, if we multiply n, 3x times x will give you a 3x squared. 3x times 2 will give us the 6x. Okay, so your 1x will be where 3x is equal to 0. And your second x will be where x plus 2 is equal to 0. So in this instance, x will be equal to 0. So when we go to look for answers, x0, x0. Okay, so now we're between two of them, and then this one, the +2 will go over to your right-hand side. So x becomes -2, which is then option 1. Okay, so important, they told us in this we need to maximize or minimize. And by saying that, we nearly need to differentiate whatever the function is. And that we will then equal to 0 to work out the x value. Okay, so whenever they use the terms you need to maximize or minimize, then it's nearly, okay, but I need to get to, again, nearly that turning point. But in this instance, we will have two turning points, so we can't use this traditional turning point formula. The way that we need to do it is to say, well, let's differentiate that. Let me quickly show you one thing, and just so with this formula where we said we need to maximize, you could have differentiated that as well. So if you said, let's differentiate y, you would have gotten minus 2x to the power of 1 plus 8. And then remember, when it's a maximizing or minimizing, that will be equal to 0. So you would have had 2x is equal to, or minus 2x is equal to minus 8. So again, you would have x is equal to 4. Okay, so the same what we got with using the turning point formula, you could have made it easier for yourself just to say, I can differentiate that formula as well. So whenever you see that you need to maximize something, if you actually differentiate that original formula, you will get your answer. So it doesn't then matter if it is a straight line, a cubic line like this one, a quadratic line like this one. Whenever you basically differentiate it, you will get your maximum point or points. Okay, so, and again, very, very, very interesting question. In this paper, they've asked a lot of these ones. So suppose total cost of manufacturing of tennis balls is given by this quadratic equation, where Q is the number of balls manufactured. What is the marginal cost when Q is 20? Okay, so marginal cost, again, is basically total cost differentiated. So if we just differentiate this formula, we get 2Q, because it's Q, the 2 goes in front, 2 minus 1, minus 4. And then they tell us, okay, but your Q is equal to 20. So 2 times 20 is 40, minus 4 is 36. So your marginal cost will be 36. Okay, so there is your marginal cost of 36 at Q that is equal to 20. Okay, so so that is, again, if even any of the previous ones, so what we now basically did here is what some of these instances, we just went a step further. So in this instance, we actually worked out what your total marginal cost is. We did not work out at how many units it will be equal to 0, because then they could have said, if we needed to work out, we would have said this function is equal to 0 to work out Q. But this instance, they ask us, here's your total cost at a marginal cost where Q is 20. What is that marginal cost? Okay. So that is, in this instance, then 36. Again, using this, that you need to know from, if I get total cost, total revenue, so any one of those, I need to nearly differentiate that to get to marginal cost or marginal revenue. Okay, so that is nearly the important thing out of a lot of these questions, is to remember that you differentiate your total cost or your total revenue to get to the marginal functions. Okay, next one again becomes a bit more difficult. So they want us to find the derivative of this function. So when I look at something like this and I see the square root, I nearly first want to simplify that. So what I would do is I will multiply in. We also see here that there is three terms, so I will multiply in and then work with that set of answers to get to an easier answer. So multiply that in is x to the power of 2. Multiply that in, it's x2 plus a half, because that is actually x a half if we put it in a fraction term. And then the last one I will for now just keep like this. We can look at that nearly last. Okay, so then just to rewrite it, I will check this out now. So let's make it not 0. We will just do dots. We will work that out last. Okay, so derivative of this, again, goes to the front, so that's 2x. So let me first check answers. 2x, 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 so all of them still valid. And we're not cancelling any of those out yet. Then that one, 5/2, x will get to, so I'm first checking 5/2. It's not there, so we can take out that one. Okay, so when you have x 5/2, and remember then it's minus 2/2 because we take away the 1 when you differentiate. So that will become x 3/2. And then that you can write as x3. Okay, so because again, that will come in and you will be able to divide by 2. So in this instance, we're sitting with this function, unless that was part of our option set, but I didn't see it. This will be what your answer will look like. So let's look at options. Okay, it's not 5. That seems correct, and it's not that. Okay, so by now we actually have the answer that we're looking for is option 3, but let's look at this that we also just need to simplify. Okay, so how I would do it is to say, okay, let's bring this one to the top. Okay, so we've done that. And then it will be the -1 that becomes -1 -2. Okay, so okay, let's just do this a bit differently. Sorry, I just quickly, let me just get some space here, and so let's just and write it better. Okay, so 1 plus x. Let's rewrite it. So 1. Okay, so x becomes 1, and this on. I'm already thinking, what's the next step, and not. So that becomes 1. X plus 2 is -1, -1, -1. So that can be -2. So that could have been the 1 if they wanted it to be at top, but obviously some of the others were not right. So again, we can write it in this format to say it's 1 over 1 plus x to the power of 2. Okay, so there we can see it's the same. That is why option 3 will be the correct one. Okay, so again, let your answers that are in the paper nearly guide you, because this option would have been fine, because this answer could have been written just as that, because we know there's a minus or there's a 1 in front, which we don't need to show. So that could have been the option in any case, but obviously that middle one was incorrect. Okay, so again, they will not give you both of these in a correct format, because you can actually, both of them are correct. So one of the terms need to be wrong, because both of them you are allowed to pick them as the correct one. Okay, so I think that is just important. Okay, so then we need to do the integral. Okay, so this is again where sometimes, again, you guys must tell me, but I think, are you using Iris or not? And are you writing open book or not? Because again, that does allow you to use a bit more things, and also it allows you to use some extra calculators and extra things like that. So I just quickly want to because there's a nice app also. Let me quickly show you. So that is why I also wanted to, so in Microsoft Edge, to quickly check if I can go into office.com. To check, and I think all of you guys through my UNISA have access to it. So that is just if you are allowed to use certain things. Okay, where is that now? Okay, so I don't see it, but there is a app in Office that is called Math Solver. I will get you, I'll show that to you. I just need to find it again. But I have also downloaded the app on my cell phone so that you guys can. Okay, I need to check for you. I will get that, but there is a Math Solver app. So let me check for you, and I will share that on the group. Okay, so for this one, if you now need to, you can put it. Some of you guys will have your formulas, or have your calculators that can do it. I just quickly want to check if I put it in my calculator, what I get, so that you don't need to nearly work out the whole process. So my answer is option 3. I quickly want to check. Just also, let me just put in numbers. Let me quickly to check this one. So if we did this, that would have been x. What is that? X squared plus x. Okay, so if we put in 4 times 4 is 16, so we get 20. I just, on the side, just quickly want to work it out. So why do I not get that? What did I miss? Okay, so obviously I missed that component as well, the square root in this. Okay, so please check all your that don't need to go through this whole process. So what I did is very simple method is to put that into my math solver to get the answer. So please just check for me. You're allowed to use study guide and notes. Are you allowed to use Excel? And are you allowed to use any online tools? I'm just so that for me is just so if you're allowed to do that, it will be great. If not, one must just then write some of these things out for you guys. Okay, cool. That will be awesome. I'm just quickly, I am quickly going to just check. I want to quickly just jot down the steps for this. Um, and so let me, okay, so yeah, that's what I thought. With this underneath, it's just not as simple to work it out like I originally had. I thought I'm taking some shortcuts. So basically, what we needed to do is like you would have done in other instances. First, we'd need to make 2x plus 1 equal to u, and then we work from there. So what I am going to quickly is going to just copy and paste a few things in, so that you also have it. I just want to see how I can do this. Let's do a few print screens. And you guys can, I will Let's make it a bit bigger. Again, what you can just, when you have time to practice it, but again, if you have the right formulas that you have, or calculators, some of this can be done by calculator as well. So please just find out what you're allowed to do and not allowed to do. Okay, so at this point, you then could have added the excess in so that you can get to your final answer. Okay, so I think that is just important. So again, sorry. Okay, so at this point, when you have it, you can put in your 4 into the x, work it out, and you can put your 0 into the x. And then your final answer would be, when you work out, will be 26 divided by that 3 at the bottom, which will then get you the 8,6967. So again, originally I wanted to take a shortcut, but yeah, that formula is not as simple to manipulate. When you integrate, you need to basically go and do it the long way around. Need to say u is equal to, then substitute, then apply the power rule. So it is just not as straightforward as I wanted it to sound like. Okay, so you will get a question on integration, so that's why also I know some of your calculators is actually able to do it. So just again, please make sure that the things that you're using, that you're allowed to use it, and if there is things that you can use, please do. So don't, if you're allowed to use certain calculators, even if you can download it as an app or something like that, I think that will be great. So just check what you're allowed to use and not. Okay, so now we're getting into, we've done a lot of marginal revenues where we got from total revenue to marginal revenue. Now they want us to move it to the other side again. So we're getting a marginal revenue and we need to get to total revenue. Okay, so remember, if we want to move from marginal revenue to total revenue, we are going to integrate this time. So a lot of differentiation that we did in the previous one, now we need to integrate. Okay, so integration. So remember, we'll work with q here. So q to the power of 1 divided by 1, just for, we can later simplify. Then minus 4 q to the power of 2 divided by 2. And then remember, here might have been a constant that has disappeared. So then just for security, we will add the c, and you can see in all of the answers as well, there was a c. Okay, cool. So what I would then do, let me, I'm going to add that a link to that integral calculator, because I think that is, and just even if you want to practice it, to see the steps. So I've included the link to that integral calculator. And let me, for the guys that might not be able to see the chat, I am putting that link quickly here in as well for you, so that you can look at it. So also just, I think it's great to always have something, if you don't know what to do next, to go and check. So this is really a nice one, and showing you all the steps. Cool. Okay, so going back to this one, just important to add the constant that, but I again don't think they will give you equation with a C and without a C. I think it will be standard that they add the C, but if there is one or two without a C and one or two with a C, always go with the one with a C, because again, it might be that constant was there and disappeared when it was differentiated the first time. Okay, so then to just simplify this, 10q, so we can look at, there's no 10q there, there's no 10q there, so there's a 10q, there's a 10q. 4 divided by 4, or 4 divided by 2 is 2. Let's see, so we can then see option 4 is the one we're looking for. Okay, so again, now they tell us question 28 is also based on this. So we need to now determine the demand equation. So remember, marginal revenue was 10 minus 4q. I'm just writing down total revenue was 10q minus 2q to the power of 2 plus c. Okay, so other way to look at total revenue is what we did way at the beginning nearly of today. Total revenue is also price times Q. So here we can say, and we want to get to a demand function. So here we can say, well, then PQ is equal to 10Q minus 2Q to the power of 2. And in this instance, we can really take away the C, because at this stage that is not going to influence anything. So we sit with a formula of P that is equal to, and let's just make it a bit simpler, over Q, and then we can cancel those two out. Remember, here we divided by Q, that's why it's at the bottom. 10 minus 2Q, so it's not that. I just want to check if we multiply that in. Okay, so not that, and here it is 10 minus 2Q. Okay, so in question, and again, unfortunately, with your exam, and I hope they don't have a question following up on a previous question, because if you had this wrong, then you will have the next one wrong as well, because you need to use that information. So again, hopefully in your exam this year, they don't have follow-up questions where the previous answer needed to be correct for you to work with the next one. Okay, and then nearly just remember, and it's very easy to forget when you see this total revenue curve or function, that there is actually another total revenue curve, which is P times Q. Okay, so I think that is nearly the important thing to look at, is that you nearly have all the formulas. And again, the formula page that I will share will give you that view, that you have all the formulas, just that it is top of mind. Oh, okay. So they've changed that a bit. So then hopefully, if it is like that, you will, the information that you need in the next one will be given. So then it might have been that from here they tell you into this one, okay, my total revenue curve is now this, because then obviously, yes, you can't go back to correct it if it wasn't right. But then at least you are able to work with it. Okay, so that would be great, because yeah, I don't. It's very unfortunate if it is questions that nearly follow up one another, and yeah, it's when you nearly lose 2 points. So that is nice if it is then sequential, but again, it makes it also, in a sense, not nice if you later on click something and realize, that is what it should have been. Then also, I know in the stats exam that is sequential, there they start off with study unit 1, and then the questions is sequential according to study unit. So it again will be nice if you guys maybe did a mock exam to say if that was nearly running like that, or if it was like we're seeing here, you could do a log function and then suddenly you go into integration. When you go back to um, working out roots, and then you go back to differentiation. So it will just be interesting if you guys did a mock exam, if it was also sequential and then according to your study guide, or if it did this whole thing we are now doing and not getting to, yeah, you're getting nearly different questions at different intervals. Okay, so the last one for today that I want to look at is again something that you will get. It is looking at, and hopefully this is big enough for you to see, but let's make it just a bit bigger. We can always come back to one of the, if we need to. Okay, so and they love to do this, so they might give you a few things. So give you these inequalities, then they give you a few options to say which of the shaded is referring to the inequalities. What they've done with this one is they said, okay, we've given you the inequalities, we've given you the shaded um, area. We want you to determine at which point, and there's 1, 2, 3 points basically, and there's a D, at which point this set of inequalities will give you the maximum revenue. Okay, so there's not really, to say, a easy way to do it. What we can look at is maybe to say, okay, at this point, my X is 0, my Y cutoff will be divided by 2 because that must be divided by 2. So my Y cutoff will be 8. So at least we know that. At this point, we don't know, so we will need to work out those two formulas and work out what the X and Y will be. And at this point, if we look at that, we know that 45 divided by 5 will be 9. So we know that X is 9 and Y is 0. So what we can do is, here's the revenue function. So we need to put in the values, get the revenue, and then check which one is the maximum. So for this point, if we put in 0, we put in 8, the total revenue is 40. Here's the answer. If we take this point, the 9 and 0, we get the 9 is 18. The Y is 0, so that will be the total revenue or marginal revenue, maximum revenue, sorry, will be 18. So there won't be a 18. So at this point, 40 is the most. Okay, so now we need to work out what is this X and Y. So we know the two formulas for this. Is X plus 2Y is equal to 16. 5X plus 3Y is equal to 45. Okay, so what will be the easiest? Let's multiply that one by 5. Then we get 5X. We get 10Y. And that times 5 is 80. And then we say the first one minus the second one. So for now, the X is 0. 10 minus 3 is 7Y. 80 minus 45 is 35. So Y is equal to 5. Put Y equal to 5 back into the first equation. So X plus 10 is equal to 16. So X is equal to 6. So we can now have this as 6 and 5 and put it into this total revenue equation. So it is 2 times 6 is 12. 5 times 5 is 25. 37. Okay, which is also an option. But then we need to maximize the revenue. So 40 is more than 37. So we will go for 40 as the one that we have selected. Okay, this was quite a different one because you would normally get this set of equations and you will need to say which one is the feasible area or not. Very seldom you will need to actually go to the points and use the points in a revenue equation to find out which one is the maximum revenue. Okay, so and then for you to get maximum revenue, it can only be one of those 2 points, or sorry, 3 points. The one that is 0 and 0, that is where it will minimize. Because if you put 0 and 0 in, it will be 0. So point D would have been where you will minimize it. But then, as we've seen, it can be any one of these 3 points. I normally would have thought that one where it is a cut through, that normally for me is sometimes the marginal revenue one, or the maximum revenue. But in this instance, it was actually that point A on this scale. Okay, so it was a shorter session today, but covering the last of this this exam paper. What we will do is again, next week we will have 2 sessions on Wednesday and Thursday, just for your final prep for next week, Saturday. So again, we'll share the presentation, we'll share the recording, and I will then share again that summary page of formulas with you guys later today. Okay, thanks for joining this session, and then we'll see later the week.
Thank you. Bye-bye.
Bye.
Bye.
Cheers.
Cheers.